Welcome to my video. In this video we're going to be looking at the second part of the binary searching algorithm for AQA's GCSE in computer science. Let's recap. A binary search is an efficient method of searching for an item in an ordered list. An advantage of it is it's more efficient and quicker than other searches as it halves the amount of data it works with at each step. A disadvantage is it requires the data to be in order, and other searches such as the linear search do not require this. The key steps. The first thing it does is calculate the midpoint. It then checks if the item that we are searching for is equal to the midpoint. If it's not, if the item we are searching for is less than the midpoint, it repeats the above steps on the left hand side, the green side. If it is greater than, it repeats the steps on the right hand side, the orange side in this example. Remember, for a binary search to work, the data must be in order, and here's an example of that. And normally, a binary search is more efficient than a linear search in most cases. On the screen I have placed the flowchart for a binary search. In a moment I am going to convert that to pseudocode, and I'm going to step through it step by step and fill in a trace table to show you how a binary search works. Feel free to print this out and follow it alongside the pseudocode so you can see they work exactly the same. So here I've got the indexes of my list. I've got my list and you can see that it's in order, and I've got my trace table. Let's begin. So I've put a breakpoint there, or what I like to call a breakpoint, which is basically where I'm stopping the code so I can see what's going on. And found is equal to false. So here I've popped found equals false. You'll see that here it's partially filled in. The example might actually give you a couple of them already filled in to start you off, just like I have here. Left is equal to 0. Now this one, list.length minus 1. So what I'm actually doing here is I'm taking how many items I've got in the list, which is 9, and I'm taking one off it, as instructed here, which gives me 8. I then come down to the while loop, and it says while found equals false. Now remember, double equals means equal to, so it reads like this. If found is equal to false, well in fact found is currently equal to false, and so both these conditions have to be true to meet this criteria. 0, which is left, is less than or equal to 8, which is right. Now that's true because found is false and left, which is 0, is actually less than 8, isn't it? Okay, so it's met it. So we come down, we come inside here. Now it says mid equals left plus right div 2. So left is 0, right is 8, so we've got 0 plus 8, okay, would give us 8, and then it's div 2. Now div is a function, and basically it divides things and ignores anything after the decimal point. It basically ignores the remainder. Okay? Now in this case there's not going to be a remainder, is there? Because 8 divided by 2 is going to give us 4. So we don't need to worry about it at the moment. Okay? So our midpoint is equal to 4. So basically the index 4, our midpoint, is now 26. And we move further down in the code. Now here I've got if list and then square brackets and inside of it mid. And this confuses quite a lot of people. And actually all it's doing is it's taking mid, which is 4, list, so here's my list, okay, and it looks up 4, so it goes inside, and inside number 4 is 26, and it just brings back 26 back. So it goes and looks up index 4, grabs the value and brings it back, which is 26. Is 26 equal to the value I'm searching for, which is 28? Is 26 equal to 28? If that was true, we'd go inside of here, but it's not, so we go to the else. Okay, so we come to the else. We go inside of the else, so we come to here. Item to find, which is 28, is greater than list mid. So list mid is 4. Let's apply that again. 26. So now it looks like this. 28 is greater than 26. Well, that's true, isn't it? Because 28 is greater than 26. So we come inside to here. And we're going to find the value of left. We take mid, which is 4, and we add 1 to it. So 4 plus 1 would give us 5. So the value of left becomes 5. Okay? So we know that now these values here are of no interest to us because we're searching for 28 and all of these are less than 28, so we can now ignore them from this point forward. We come back round the loop, so we're now here. If found is equal to false, okay, so let's check. So found is still equal to false. Left, which is currently 5, is less than or equal to 8. Well again, that's true, so we can come inside the loop again. Well actually we never left the loop, we've stayed inside of it, okay, because the condition's still met. Mid. So to work out mid, we take left, which is 5, and we add right to it, which is 8. So 5 plus 8 would give me 13. Now this is what I was talking about earlier. If we were to divide 13 by 2, we would get 6.5. Now, because this is using the function div, okay, it ignores any remainders or anything after the decimal point, okay? So basically, it's 6.5, we just wipe it off. Using integer maths, it becomes 6. So our new midpoint is now 6, okay? So index 6 has the value 34 at it. So we come down to the if statement. Now, before I put it up on the screen, let's see if you can work it out. If list mid, now mid is 6, index 6, list 6, pass it in. So what do you reckon it'll be? So we've got list, so it's list mid 6, so that'll be 34. Is 34 equal to 28? Let's have a look. Okay, yeah, that's right, because the 6 went there, we went to there, grabbed the 34, brought it back, and the value we're searching for is 28. Is 34 equal to 28? Well, no. So we come down to the else again. And we go inside the else to the if statement. And we get to here. Item defined is 28. Is it greater than list mid? So mid is 6, so we pass 6 in. We go and grab what's at value 6, which is 34. Is 28 greater than 34? Well, 28 is not greater than 34. So we wouldn't go inside of here. We'd come down to the else. We'd go inside of the else. And now we're here. So now we're going to calculate right. So to calculate right, we take mid, which is 6, and we take 1 from it. Okay, 6. So right equals 6 minus 1, so right becomes 5. And we fill right in there. And now we come back round the list again. Okay, now we know that the value here is of no interest to us, because we know that 34 was greater than 28, so anything 34 onwards is too high. So we come back round the loop, and we are here. Found equals false. Well, found is still false because it's not changed in our trace table. Okay, and left, which is 5, is less than or equal to right, which is also 5. That's interesting, isn't it? So this time they are equal to each other, so that condition's still true, so we can come inside. So we come inside, look, and we are here. So mid equals left, which is 5, plus right, which is also 5. So now we've got 5 plus 5 gives us 10, divide it by 2, okay, gives us 5. So mid is now 5, okay? So we come down to here, list mid. So we go to mid, it's 5, so we're going to look at 5, it's 28. So this is now 28. Well, 28 is equal to 28. We're getting somewhere, okay? Now this condition's true because 28 is in fact equal to 28. So the found becomes true, okay? And you'll see that we've updated the table to true. And that's basically how the pseudocode will work for a binary search. I hope that's helped. Feel free to slow it down and have a look yourself if you need to, okay? Right then, challenge for you. I have blurred out the actual code to create a binary search. Okay, so I've blurred it out, and this is the outcome I've got, where it says 26 is not equal to 28, 34 is not equal to 28, 28 is equal to 28. So basically, I have done that code there. I have actually wrote the physical code for it. So what I'd like you to do now is pause, and using my pseudocode, see if you could convert this into the actual code. Now, on the count of 3, I'm going to show the answer. So if you want to do that, make sure you've paused before I count to 3, otherwise the answer is going to be shown. 1, 2, 3. So there you go. So there's the answer. So you can check that. Now, that's not the only way to do it, okay? But that way has worked. It's quite efficient, and it's done exactly the job. And basically, this is a little challenge that you can have a go with yourself. Now, what you could do is you could have a play by adding some extra numbers on the end, okay, and see if it still works. Now, it will still work. Here's something you might want to try, so for you to think about. What would happen if I added 16 here, 11, 12, 99 and 72? Have a think about that. Think back to the first slide, okay, in part 1, okay, and part 2. Have a think about it, alright? And I'll give you the answer now. So obviously the answer is that the list would not be in order, so it would not work, okay? It would come back and stop basically when it starts to go out of order. Okay, have a go, give it a try. So, to recap, the binary search, there is the steps. I'm not going to read them out again because I've read that twice now in the part 1 and part 2, but pause if you need to. Okay, thank you for watching. I hope you've enjoyed part 1 and part 2. If you've got any questions, feel free to contact me.